All right, guys, so to start you off today, we are going to do the 13-2 in-class example. It's on page 251, so let's make sure that we are all there, and we are going to go through one example together. All right, so what you guys are doing in today's worksheet is you're going to be verifying different identities. There were two main techniques that I gave you guys in the notes for the video that you should have watched last night. The first thing is that it always makes the most sense to get things back in terms of sine and cosine. The second thing is that you want to start with the more complicated side and simplify that down. So this one, if you're looking at this, you might be thinking to yourself that these are both relatively complicated sides, and they are. A rule of thumb is that even though, for normal arithmetic, addition and subtraction is easier, when you're simplifying things, addition and subtraction is actually the more complicated side compared to any multiplication or division. Because remember, to add or subtract, you have to have a common denominator. To multiply and divide, you don't. So if you're trying to choose between the two sides and you don't really recognize which one is the more complicated one, if there's a side that has addition and subtraction and the other one does not, then the side that has addition or subtraction is the more complicated of the two. So we're going to start with this right-hand side, and our goal is that we'll be able to simplify it until it looks exactly like the left-hand side. And once you show that the two sides are actually exactly the same, that means that you have verified that identity. Okay, so we're going to start with the right-hand side, and like I said, just manipulate it until we're able to make it look like that. So right-hand side, we're going to start with this. So the first rule I mentioned is that you want to get everything in terms of sine or cosine. So cotangent squared, I have a list of identities that we worked with on Wednesday. So cotangent's definition is cosine divided by sine. And if it's squared, it just means that you square each piece. So this I can rewrite as cosine squared over sine squared. So cosine squared over sine squared. So that's cotangent squared, just a quick rewrite based on this identity right here. Minus, and then the cosine squared, that's already cosine. So we just leave it. Okay, so it looks like this so far. And I mentioned the whole adding, subtracting with a common denominator thing. You'd be stuck at this point without getting a common denominator. So we are going to get a common denominator. This one technically right now just has a denominator of 1. Whereas this one has a denominator of sine squared. So we are going to multiply this right-hand side, top and bottom, by sine squared, and then that will give us a common denominator, and once they have a common denominator, then we'll be able to combine those up. Okay, so see what I did here? They now have the exact same denominator, and I'll be able to add them together, well, subtract them. So this is equal to, I'm going to move up here a little bit, cosine squared minus, and you can just subtract straight across. Be careful on what you're combining. These two pieces on the right are multiplied together, so you can't just combine them yet without doing some simplifying. Okay, so what I can do, this piece and this piece both have a cosine squared in common, so I can factor that cosine squared out. So I'm going to do that. So cosine squared is going to come out front, and I'm going to factor that out. So when I factor a cosine squared out from this, I'm left with just a 1, minus, and then when I factor a cosine squared from this, I am left with a sine squared. Sorry to squeeze that in. And then the denominator is just a sine squared. All right, so I kind of have two different pieces here. So I have my cosine squared over sine squared, and then I have my 1 minus sine squared. So I have two different pieces, and I'm going to be able to simplify those two different pieces up. So start with this piece right here. Okay, this cosine squared divided by sine squared. According to this, cosine squared divided by sine squared is just cotangent squared. So this part that I just circled right here, that is the same as cotangent squared. So that's this part that I circled is the same as cotangent squared. Because remember, our end goal is to make it look like this. And then this part, the 1 minus sine squared, that actually comes from this expression right here. So if I want to get cosine squared by itself, what I would do is I would subtract the sine squared from both sides. I'm going to show you. If we subtract sine squared here, subtract sine squared here, this would then be by itself, and this would be 1 minus sine squared, which is exactly what I have right here. So according to that property, this is the same as just cosine squared. So this part is just equal to cosine squared. So a little bit of manipulation, and of course multiplication, the order doesn't matter. So this is cotangent squared times cosine squared. This says cosine squared times cotangent squared, but those end up being exactly equal. So there's really not anything to box in with these verification problems. I just kind of always like check, like, yep, we're done. They are equal to each other. So that is your in-class example for today. Again, you guys have a worksheet that you're going to be working on, and that's going to be due at the end of class.